images formed by concave mirrors? Do they have the same characteristics? You all must have seen the reflection of your face in a spoon. Spoon has two smooth surfaces, one curved inside and the other curved outside. However, it is not perfectly spherical. For ease of understanding, we can consider the reflecting surface which is curved inwards as a concave mirror. I will show you how the image appears, but using an actual concave mirror and not a spoon. So let's try and find out the properties of an image formed by a concave mirror. I will show you two views of the mirror, the front view and the side view. The side view is just to show the different positions where the object is kept, as it's difficult to do that in the front view. Okay, so let P be its pole, C its center of curvature, this line is the principal axis, and the F is the principal focus, also called focal point. Assume that initially the object is kept close to the mirror. I will make a table on the right with 3 columns telling us where the object is kept, the size of the image formed, and the nature of the image, that is, whether the image is virtual or real. So initially the position of the object is between F and P. What is the size of the image? We see the reflection in the concave mirror and the image is bigger in size. We see that it's enlarged. The dimensions of the image are greater than the dimensions of the object. So we say that when the object is between the principal focus and the pole, the image formed is enlarged. Also, is the image upright or erect? What about the nature of the image? Is it real or virtual? Yes, it's the virtual image. It appears to be formed behind the mirror. You will find that as I move this object away, its image gets even bigger. And when the object is at the principal focus, the image is huge. We say that when the object is at the principal focus, the image is highly enlarged. Is it a real or a virtual image? It is a real image. Since it's a real image, it's upside down. Or we use the other word for it, which is inverted. It is formed on the same side of the mirror as the object is. And believe it or not, the image is actually formed infinitely far away. When I start moving this object away from the focal point towards point C, the image is still enlarged, but the size is reducing. And what is the nature of this image? Yes, here as well, the image is upside down. It's a real image. When the object is at point C, the image is still real and inverted, but now the size of the object and its image is same. Yes, at this point, both the object and the image are of the same size. What next? If I move this object beyond point C, the image remains real and inverted, but now the size of the image is actually smaller compared to the size of the object. So we say that the image is diminished. This is also a real image. As the objects keep moving beyond C, the size of the image keeps on reducing. What if the object is placed at infinity? Well, if you remember that in our previous video, we saw that the rays of light parallel to each other as well as to the principal axis will converge at the focal point. And in that example, our object was the sun. Sun is at a very large distance away from the earth, and hence we consider the rays of light from it reaching the surface of the earth to be almost parallel. The image of the sun will be formed at the principal focus. Similarly, if any object kept infinitely far away from the mirror on the principal axis, all the rays from it can be thought of as traveling parallel to each other. After reflection, they will all converge at the focus. And the image of that infinitely far away object will be formed at this point. Yes, this is a point-size image. It's a highly diminished image and it's also a real image. Take a moment and go through the properties of images again. From this table, you can see that the image is virtual only when the object is kept between the focal point and the pole. Otherwise, the image formed is always a real image.